we have these two equations here. This equation is an equation in two variables, x and y. This equation is also an equation in two variables, x and y. So these two are equations in two variables, x and y. But the catch is that these are not linear equations in two variables, because the power of x and y is not 1. 2 by x is equal to 2 into x to the power negative 1. So the power of x is negative 1, and hence this is not a linear equation. The power of x and y in this equation is not 1. Hence it is not a linear equation. Similar is the case with this equation. Even this is not a linear equation. So how do we solve them? Well, we can solve them if by some way we can transform them to linear equations in two variables. Let us see if we can do that. We have x in the denominator in both the equations. Also, in the second term, we have y in the denominator. So the first equation can be written as 2 into 1 by x minus 3 into 1 by y is equal to 15. This is just another way of writing the first equation. The second equation can be written as 8 into 1 by x plus 5 into 1 by y is equal to 77. This is what we have. Now we have 1 by x and 1 by x here. So this is the variable part of the first term. If we can substitute 1 by x as a, similarly, in the second term, if we can substitute 1 by y by a variable b, that is, substitute 1 by x as a and 1 by y as b, then the first equation will become 2a minus 3b is equal to 15. And the second equation will become 8a plus 5b is equal to 77. So we have substituted 1 by x is equal to a and 1 by y is equal to b. A and b are variables because x and y are variables. So as x varies, a varies. As y varies, b varies. So we have 2a minus 3b is equal to 15. We have rewritten the first equation in this manner and the second equation in this manner. Now, these two are linear equations in two variables a and b, because the power of a is 1, b is 1 in the first equation. The power of a is 1 in the second equation, as well as b is 1 in the second equation. So these are two linear equations in two variables a and b. So now we have two linear equations in two variables a and b. We call them equation 3 and equation 4. And let us solve them. So let us solve them by the elimination method. The coefficient of a is 2 in the first equation and 8 in the second equation. The coefficient of b is negative 3 in the first equation and 5 in the second equation. So we see that the numerical part of the coefficient of a or b is not the same in any of the equations. So we need to transform these equations and bring it to a form where we can eliminate one of the variables. Observe that 8 is a multiple of 2. So if we can transform this equation by multiplying it with some number and make this part, that is make this 2, 8, then we can use elimination. So let us multiply this equation by 4. So if we multiply equation 3 by 4, that is, we multiply both the sides of equation 3 by 4, we get 8a minus 12b is equal to 60. And we rewrite equation 4. So 8a plus 5b is equal to 77. This is what we have. Now the numerical part of a is the same in both the equations. Look at the signs. This is positive, this is positive. So they have the same sign. When we have the same sign, we need to subtract one equation from the other. So let us subtract this equation from this. On subtracting this, first we need to change the signs of the second. So this is plus, we make it minus. This is plus, we make it minus. Even this is plus, we make it minus. So we need to subtract this from this. We change all the signs. Now 8a, consider this sign. 8a minus 8a gives us 0. Negative 12b, negative 5b gives us negative 17b. 60 minus 77 gives us negative 17. So this is what we have. Negative 17b is equal to negative 17. Now solve for b. This gives us b equal to 1. So we have got the value of b. Now we can easily get the value of a by putting this value of b in any of these equations. So let us put b equal to 1 in equation 3. So we have 2a minus 3b. So in place of b, we put 1. So 3 into 1 is equal to 15. This is what we have. 2a minus 3 into 1 is equal to 15. So 2a minus 3 is equal to 15. Or 2a is equal to 18. We take negative 3 to the right hand side. So it becomes plus 3. Or a is equal to 18 by 2. That is 9. So we get a is equal to 9. So b is 1, a is 9. This is the solution of this pair of linear equations. So we have got the value of a and b. But we actually want to get the value of x and y in order to solve this pair of linear equations. So we use this value of a and b and this substitution which we have used to get the required value of x and y. So a is equal to 9 and b is equal to 1. Now put these values of a and b in 1 by x is equal to a and 1 by y is equal to b. We need to put these values of a and b in these two. So 1 by x is equal to 9 because the solution for a is 9. Or x is equal to 1 by 9. So this is the value of x. Similarly, for y, 1 by y is equal to 1 because b equal to 1 is the solution. Or y is equal to 1. So x is equal to 1 by 9 and y is equal to 1 is the solution of the given pair of equations. Although the pair of equations was not linear, but we transformed it using some substitution into a pair of linear equations in two variables and solved for x and y. These are two equations in two variables x and y. So let us call these as equation 1 and equation 2. But observe, that these are not linear equations? Because 1 by 2 root x is equal to 1 by 2 into x to the power negative 1 by 2. So the power of x is not 1. Hence this is not linear. Similarly, this equation is not a linear equation in two variables. So how can we solve them? Well, we can solve them if we can reduce them to linear equations in two variables. Observe that we have root x and root x in the denominator of the first term in both the equations. Also, we have root y and root y in the denominator of the second term in both the equations. So, we can take this 1 by root x from here and 1 by root x from here, because these are common and this is the variable part. So we have 1 by root x, and if we take it to be a, also we can take 1 by root y from here, 1 by root y from here. This is common to the second term of both the equations, and also this is the only variable part. So 1 by root y is equal to b. Let us make this substitution and see what we get. So the first equation becomes a by 2 plus b by 3 is equal to 2, because 1 by root x is written as a, 1 by root y is written as b. The second equation becomes a by 3 minus b by 4 is equal to negative 1 by 12. So this is what we have. Now these are two linear equations in two variables, a and b. Why linear? Power of a is 1, b is 1. Power of a in this equation is 1, power of b is 1. So these are two linear equations in two variables, a and b, and we can solve them. So let us solve them now. First of all, we try and get rid of the fractions. So in equation 3, we see that we have 2 and 3 in the denominator in the left hand side. So we take the LCM of 2 and 3. So the LCM of 2 and 3 will be 6. So we multiply this equation by the LCM of 2 and 3. Multiplying this by 6, we get a by 2 into 6 gives us 3a plus b by 3 into 6 gives us 2b equal to 2 into 6 gives us 12. So let us call this as equation 5. 3a plus 2b equal to 12. Let us call this as equation 5. Now, look at this equation. So, we have 3, 4 and 12 in the denominator. So, we take the LCM of 3, 4 and 12. The LCM of 3, 4 and 12 is 12. So, let us multiply both the sides of this equation by 12. So, a by 3 into 12 gives us 4a. Then we have a minus sign. b by 4 into 12 gives us 3b equal to negative 1 by 12 into 12 gives us negative 1. So this is what we have. 4a minus 3b is equal to negative 1. Let us call this equation 6. Now, let us solve equation 5 and equation 6 in order to get the values of a and b. So, we have equation 5 and equation 6. Let us solve it using the elimination method and get the values of a and b. Now, the coefficient of a is 3 in the first equation and 4 in the second equation, so they are not the same. The coefficient of b is 2 in the first equation and negative 3 in the second equation. So the numerical part of the coefficients of a or b is not the same in the two equations. So we need to transform these equations so as to get the same numerical part of any one of the variables so that we can eliminate it. Since 2 and 3 are smaller numbers than 3 and 4, let us eliminate b. Now, in order to eliminate b, first let us consider what is the LCM of 2 and 3. The LCM of 2 and 3 is 6. We need to have 6 here. So, we should multiply this equation by 3 in order to get a 6 here. So if we multiply this equation by 3, we will have 6 here. What about this equation? What should we multiply it with in order to get 6 here? We should multiply this equation by 2. So let us multiply these two equations by 3 and 2 respectively. So 3 into 3a gives us 9a. 3 into 2b gives us 6b, and 3 into 12 gives us 36. 2 into 4a gives us 8a. Then we have a negative sign. 2 into 3b is 6b equal to 2 into negative 1 is negative 2. So we have these two equations. Now the numerical part of b is the same in both the equation, but the signs are opposite. That is, we have a plus here, we have minus here. So we have different signs. When we have different signs, we add the two equations. So let us add these two equations. 9a plus 8a gives us 17a. 6b minus 6b gives us 0, equal to 36 minus 2. This gives us 34. So we get 17a is equal to 34. Now a is equal to 34 by 17, that is 2. So we get a is equal to 2. Now we can get b by substituting this value of a in any of the equations. So let us put a equal to 2 in equation 5. So we have 3a, that is 3 into a. In place of a, let's write 2. 3 into 2 plus 2b equal to 12. So we get this by putting a equal to 2 in equation 5, or 6 plus 2b equal to 12. 2b equal to 12 minus 6, that is 6, and b is equal to 6 by 2, that is 3. So we get b is equal to 3. So a is equal to 2 and b is equal to 3 is the solution of this pair of linear equations. But we actually want the solution of x and y. So let us use these values and our substitutions, that is 1 by root x equal to a and 1 by root y equal to b. These are the substitutions which we had made. Let us use these substitutions and these values to solve for x and y. So putting the value of a and b now, 1 by root x becomes equal to 2, because a is equal to 2 is the solution which we have got. Now square both the sides. So we square both the sides and we get 1 by x is equal to 4. 1 square is 1, root x square is x, and 2 square is 4, or x is equal to 1 by 4. This is what we have. X is equal to 1 by 4. Now let us solve for y. 1 by root y is equal to b. b is 3. So we have got b as 3. So 1 by root y is equal to 3. Now square both the sides. So we square these two. 1 square is 1 by root y whole square is y is equal to 3 square, which is 9. So 1 by y is equal to 9, or y is equal to 1 by 9. This is what we have. So x is equal to 1 by 4 and y is equal to 1 by 9 is the solution of the pair of equations in two variables x and y which we had. Although the system of equations was not linear, but we made these substitutions and transformed it into a system of linear equations in two variables, solved for the values of a and b, and then substituted the values here to get the final values of x and y.